All right, the next kind says we are going to estimate the standard deviation of our group data. So basically, we're going to use the same formula once we get to the end, but remember last time when we had these things right here, we had to find the midpoints and multiply it by the number of items in each group in order to find the mean. So when we find our mean here, first of all, we're going to find the midpoint of each of these little sections. The midpoint of -8 and -4 would be?
-6.
-6. Halfway between, or add them together and divide by 2. The midpoint of -4 and 0 would be? -2. The midpoint of 0 and 4 is? 2. The midpoint of 4 and 8?
6.
Is 6. So now we're going to take each of our numbers that are in our table here, multiply them times those midpoints. So we have 6 times -6, which is -36. We would have 15 times our -2, which is going to be -30. We have 24 times our +2, which is 48. And then we have 3 times 6, which is 18. We're going to add those together, which in this case, if you add those together, you get 0. And then what we'd really be doing is taking the 0 and dividing it by 48, because we have 48 total numbers, which is still going to give me 0. So the estimated mean of this list of data here would be 0. Now we're going to plug that into our formula for standard deviation. By the way, we're doing a sample standard deviation here, and so we get to take all our values here, and when we plug these in here, what we're going to do is we're going to take this number here, that's from our number from our table of how many items we have, and we're going to multiply it by this number here that was our midpoint minus our mean, so -6 minus 0, and then of course we get the little squared there from our formula. So the next one, we had 15. The midpoint was -2. We're going to subtract the mean of 0, and we're going to square that. The next one, we had 24. Our midpoint there was 2 minus the mean of 0, and we're going to square that. And then the last one, we have 3. Our midpoint there was 6, so 6 minus 0 squared. On the bottom of this fraction again, we're going to use n minus 1. N, our total number of things was 48, so 48 minus 1 means we're going to end up with a 47 down there.
You just want the top number first?
I just want the top number first to make sure you get that all punched in right. You already got it in there, 480. You were quick. 480 over 47. Then we're going to take the square root of 480 over 47. Rounding this to 1 decimal place this time, it says in our directions.
3.2.
So 3.2 would be our estimated standard deviation of our group data. So most of the data would be between 3.2 of either side of the middle. Yeah, most of the data is there within 3.2 of either side of my middle. All right, so number 11 again. Senioritis is temporary non-fatal illness afflicting thousands of high school and college seniors every year. Its chief symptom is a desire to be done doing anything but schoolwork. So, they're talking about having a senior skip day over the past 50 years, and they've given us some data here on how many students actually miss on senior skip day. First thing again, we're going to find the midpoints of each of our little sections of our bars on our histogram.
60, 70.
You got 30, 40,
60, 70.
50 in there?
Yeah,
60,
50,
70.
60, 70.
30, 40, 50, 60, 70 would be our midpoints. All right, so now we need to estimate the mean by taking the number from our bar times the midpoint of the bar. So 5 times 30, 15 times 40. Why am I writing 14? $20 times 50, 5 times 60, and 5 times 70.
It's 150, 600, 1,000, 300, and 350.
And then we're going to add all those together.
To 2,400.
2,400. And we're going to take that 2,400 and divide by the total, which is 50, since we did our data over the past 50 years.
48.
48 is going to be our estimated mean then. We now have to plug that into our formula. So, first one, we have 5 in that on that group, and then we're going to do 30 minus our 48 squared then. And the next one we had 15, and we're going to have 40 minus our 48 squared. The next one we had 20, and then we're going to have 50 minus our 48 squared. The next one we had 5, and we had 60 minus our 48 squared. And then we have 5 again, and we had 70 minus our 48 squared. On the bottom, we're going to do n minus 1. So 50 minus 1 means we're going to have 49 down on the bottom, right?
Uh, 5,800.
We got 5,800 on the top, 5,800 over 49 then, and we got to do the square root of that and round it to 1 decimal place.
10.88.
So rounding
Or
it off to
10.
1 decimal place, we're going to go 10.9.
9.
10.9. Now if you do put in 10.88, they're going to count that okay because they actually said to at least 1. And so if you do more than 1, as long as you round it correctly, you're okay. Normally I just round to whatever place they say. By the way, if you're looking for math symbols, if I'm doing the estimated mean, the symbol looks something kind of like a U. It looks something like that. So when you have X bar, that means you have the actual mean that you've calculated. When you have that little U symbol, it means you're doing the sample or the estimated mean because I don't have exact values. So if you see that symbol, number 12 then, same thing that we just did. First thing we're going to do is find the midpoint of all of our bars in our histogram.
2, 6, 10, and 14.
2, 6, 10, and 14. We're then going to multiply each of our numbers from the top of our bar times the mean, or times the midpoint. So 3 times 2, is that a 9? 9 times 6, 18 times 10, and 6 times 14. 654, 180, and
84.
84. Adding those all together, we would get 324. So finding the mean, 324 divided by 36 students from our university, right?
9.
9. So our estimated mean is 9. I didn't leave myself much writing room to put in my formula here to find my estimated standard deviation. So we have 3 times 2 minus 9 squared plus 9 times 6 minus 9 squared plus 18 times 10 minus 9 squared plus 6 times 14 minus 9 squared. Divided by 36 minus 1, which means I'm going to have a 35 on the bottom then, right?
396.
So 396 on the top, 35 on the bottom. If I do the square root of 396 over 35, I get
8.9.
Try that again.
Oh wait, 396 what?
396 over 35.
Oh, 5. I don't know. 3.4.
3.4 sounds better. So that means from the middle, if I went over 3.4 in each direction, I would have most of my data in that section, which I do.